in Iran. And now I want to talk about my presentation entitled with damp response of sandwich composite structures integrated with MR fluid under impulse loading. As you know, MR fluid is a new category of smart materials that the total name is magneto-archaeological fluid. And if I want to talk about the outline of this presentation, at the first, I want to talk about the motivations and the history of MR fluid, layer-wise modeling, fabrication of samples, and experimental of MR laminated beam, damping coefficients, materials effect, and conclusion. Laminated composite structures or beams are being used in many engineering applications, such as wind turbine blades, helicopter blades, arms of the robots, and satellites, and many other engineering applications, as you know. And MR fluid, or in other words, the advantages of composite structures consists of the below items. The first one is higher strength to weight ratio and higher stiffness to weight ratio. And the composite structures have higher strength with low weight. And these structures improve thermal insulation, and the transportation are more easier than other materials such as metallic counterparts, and the maintenance is more easier than other materials, and the fuel consumption and cost are very lower than metallic counterparts. Because of that, we want to use this material in order to improve the dynamic behavior of structures. Excuse me. As you can see, after a period of time, the structures have sudden failure sudden failure, and in order to improve the failure or dynamic behavior of structures, we want to use the MR fluid or magneto-archaeological fluid. MR fluid are a new category of intelligent materials with individual components that change rapidly by applying magnetic fields, and consist of carrier fluids, ferromagnetic particles, surfactants, and additives. MR fluids improve the natural frequencies, dynamic behavior, stiffness, and damping coefficients of structures. In below figure, you can see the molecules of MR fluid by applying the magnetic fields and without applying magnetic fields. In order to determine the complex shear modulus of MR fluid, we can determine the G prime and G double prime. The summation, the addition of G prime and G double prime is the amount of complex shear modulus. And complex shear modulus is dependent on magnetic field intensities and applied frequency for driving the beam. By applying the standard test, we can show that the amounts of G prime and G double prime are showing here. And in this project, we use the layer-wise theory in order to determine the damping coefficients and dynamic behavior of the structures. Because layer-wise theory, the accuracy of the layer-wise theory is much more accurate than other methods such as FSTT and CLPT. And in this formula, the displacement of the layer N is defined but with other parameters such as U0 and W0. The contribution of this section compared with other formula is that if you select your specific layer, for example, N is equal to 5 or N is equal to 3, you can manage and derive the equations of motion of composite structure for specific layers. And the equations of motion of MR laminated beam, by considering the Hamilton principles, are defined by this formula. In this formula, delta of U is the virtual strain energy, and delta of W is the virtual work, and delta of K is the virtual kinetic energy. As I said in previous slide, the equations of motion for layer N of MR laminated beam obtained by this formula. For example, if you select the number of N is equal to 5, you can derive the equations of motion for 5 layers. In order to validate the results with experimental, at the first, we cut the 8th layer of plain woven e-glass, fiber carbon, and Kevlar in order to build a specific MR laminated beam. After that, by hand layup method, we can use the structure, and at the end we put it into the autoclave for 560 minutes at 85 degrees centigrade. And in next step, the plate cut into beam strips and the sample of MR laminated beams are ready. And in order to build the sandwich structure, we use the MR fluid with the commercial brand of MRF 132DG, built by Lord Corporation. And we can inject the MR fluid between the layers of the composite. In this section, you can see the different composite materials or different MR laminated beams with different materials such as e-glass, fiber carbon, and Kevlar. And in order to determine the damping coefficient of MR laminated beam, we need the shaker and sample of MR laminated beams, and the signal analyzer, power amplifier, and electromagnetic and volt and ampere meter. The shaker is used to generate the white noise with power spectral density of 40 decibel in the range of 0 up to 800 hertz. And by applying the magnetic fields from 0 up to 2100 Gauss, we can determine the damping coefficients and natural frequencies of MR laminated beams for each materials in by applying the specific magnetic fields. This figure shows the FRF of different composite materials. In this figure, it is obvious that the FRF of e-glass is lower than fiber carbon and Kevlar. In other words, this phenomenon means that the natural frequency and damping coefficient of e-glass is lower than fiber carbon and Kevlar. And the mechanical properties of different composite materials show that the mechanical properties of Kevlar is higher than fiber carbon and e-glass. E11 and the rho or density of Kevlar are much bigger than fiber carbon and e-glass because totally Kevlar is harder than fiber carbon and e-glass material. In order to determine the damping coefficient of different composite material of MR laminated beams, we can use this formula. By selecting this formula, and based on the below table, the damping coefficients of Kevlar, for example, in zero Gauss magnetic field, is bigger than damping coefficients of fiber carbon and e-glass. By applying the magnetic fields up to 1,400 Gauss, the amounts of damping coefficients for e-glass, fiber carbon, and Kevlar have been increased. But beyond this value, the amounts of damping coefficients for all materials started to decrease because after the 1,400 Gauss, the molecules of MR fluids have started a unpredicted behavior. And by applying the impulse loading, these three figures shows that the displacement of e-glass, fiber carbon, and Kevlar, and the responses of the structures show that the MR laminated beam made of Kevlar provide the highest amplitude, and e-glass materials has the lowest amplitude. In addition, for all materials, by applying the magnetic fields, decreasing the amplitude of displacement and settling time. Totally, in this presentation and in this formula, the damping coefficient of different materials of MR laminated beams subject to magnetic fields have been investigated based on the N layer of the layer-wise theory, and the mechanical properties of MR laminated beams made with harder materials are higher than softer materials. As you know, MR laminated beams is the meaning of the laminated composite beams incorporated with magneto-archaeological fluids. And damping coefficients of e-glass of MR laminated beams are lower than damping coefficients of MR laminated beam made by fiber carbon and Kevlar. In addition, damping coefficients of MR laminated beam made by Kevlar are generally higher than another material. As I said that by applying the magnetic fields, the amounts of damping coefficients of different materials of the structures have been increased, and this phenomenon is due to the mechanical properties of different materials of laminated composite beams. And the present work may potentially help to designers and manufacturers in order to optimize the cost of the materials by selecting the low-cost materials. Thank you very much for your attention. If you have any question, please let me know.